Okay, so today we are doing linear and quadratic systems and inequalities. So today is all about solving systems of linear and quadratic equations. So I'm going to wait until I'm sure everyone is listening before I start. Lucas, Willem, Jackson. Okay, so today we're talking about linear and quadratic systems. And so we'll remember linear are straight lines and quadratic are parabolas like that. Okay? Oh yeah, like that, look like that. Yeah. Okay? So when we're talking about a system of equations, it just means that we have an equation that's linear and we have a different one that's quadratic. Okay? So if we look down at example number 1, we have our two equations, our quadratic one there and our linear one here. And the first thing they ask us to do is to find the intersect graphically. So this is something we've been doing for, I would say, approximately 2 months now, right? So we go y1 is equal to x squared, y2 is equal to x plus 6, x plus 6. We can hit graph. And then we find our intersecting points, just like we always have, right? So we go second trace, intersect, enter, enter, enter. We say, okay, well, we have one at -2 and 4. So that's this one here. And then we have the other one. So we just have to move this over really close to it. Enter, enter, enter. And it's 3 and 9. Just like that. Okay? So this, I really hope, isn't anything new to you today. So one thing we do go over today is how to do this algebraically. So when we look at our two equations, we have y is equal to x squared and y is equal to x plus 6. And we can notice that both of these equal y, right? So they both equal the same thing. So we can actually make our two equations equal to each other. So because they're both equal to y, which is the same thing, we can put them together like that. Okay? When you get it to this point here, you can just solve it like you would any other quadratic. So we know when we're solving quadratics, we want to move everything onto the other side. So I'm going to get x squared minus x minus 6 is equal to 0. So you can use the quadratic formula. One like this, though, you should be able to look at it and say, oh, that's going to be x minus 3 and x plus 2. Okay? But yeah, absolutely. Don't forget to use the quadratic formula for the tough ones. Okay? And then just like we've been doing for a long time now, we say, okay, if we set each factor to equal 0, we can find what our x's are. So we get x is equal to 3 and x is equal to -2. So this is great because we found our x's now, but in the question they were asking for the coordinates. So we need to figure out what the y's are as well. So all you have to do for that is take your two x values and sub them into one of your equations. Okay, it doesn't matter which one. You can use this one or this one. But don't make your life harder than it needs to be, right? Choose to sub it into the easier of the two equations. So in this case, they're both pretty simple. But if one equation was a lot longer and had a lot more variables than the other one, I would definitely use the more simple one. Okay, so for x is equal to 3, I'm going to sub it into, I'll do the x squared one. X squared, y is equal to 9. So the point we get is 3 and 9, which is good because it matches with what we found in our calculator. Okay. And then you want to do the other one too. x is equal to -2. So y is equal to -2 squared, and y is equal to 4. Absolutely. Okay, so here's our two coordinates, and it's awesome because they match what we found in our graphing calculator. So this is a way you can check your work. If the question is to do it algebraically, if you have time, do it graphically as well, and you should get the same answers. Okay. For part C, they ask us to verify. So this kind of brings us to Josh's question. When they ask you to verify algebraically, what they want you to do is put it into that x value into the other equation. So we can go x is equal to 3, and we're, yeah, basically it's like, oh, we found it for one, let's make sure it matches up with the other. And then we get y is equal to 9. So we get 3 and 9. And then we get -2 and 4. Okay, so you should always get the same answer when you verify. Okay, if you don't, check your math somewhere because it means a mistake was made somewhere along the line, whether it be in here, or maybe here, or even here. Somewhere a mistake was made. Okay, so flip the page. So, yeah, it's a giant graph. So what we have here, this is our graph of this. So we know it's a parabola, so it's a quadratic. So x squared minus x minus 12. And then they ask us to algebraically determine the points of the intersection of the line. So we know that our two equations are x squared minus x minus 12 and 3x. And because they're both equal to y, we can make them equal to each other. So say, for example, instead of this here, we gave you something like this. Okay? If you get something that's not in a y equals form, all you have to do is change it into a y equals form. So for example, with this one, if you subtract x from either side, you get y is equal to x squared minus x minus 12. Right? So you may not necessarily get it in that y equals form every time, but usually you can put it in that form quite easily. Okay? So we'll just solve this like we've been doing all along. So we get x squared minus 4x minus 12 is equal to 0. And we want to find our factors, which we know is x minus 6 and x plus 2. And then we just want to find what our x is actually equal. So we know that x is equal to 6 and -2. Okay. So when we're finding our points of intersection, though, we know that we have to plug these two values back into one of our original equations. So I'm going to use this one because it's way easier. So I'm just going to say x is equal to 6. So we know y is equal to 3x. So y is equal to 3 times 6. Y is equal to 18. Just like that. Okay. And then for the other point, we do the same thing. Okay, so here's our two intersection points. Okay. So I'm going to attempt to, for what? Because I used two different values of x. Okay, so I tested both of these. If I had plugged the 6 into this one here, I should get 18 again. Okay, so I'm going to attempt to plot this. It's kind of tough because the graph is bigger than my page. I'll go -2, -6, so we have 1 point there. 6 and 18. And 1 point there. So the graph is going to go like this. Okay. So we can see that we have 2 intersection points, and that this line here this one is 3x right there. Okay? So now they're asking us to do the exact same thing, except instead of 3x, we have 3x minus 16. So we know that because they both equal y, we can set the two equal to each other. So I'm going to minus 3x from both sides. And add 16 to both sides. Okay. And then we just factor it like we normally do. So we say, okay, well, the two factors of this are both x minus 2. You got it. Okay, so we know that our x is equal to 2. And we can go ahead and put that right into one of our equations. So I'm going to put it into the linear one, just because I find it's a little bit easier. So that's that one. And y is equal to 3. It's 2 minus 16. Like that. Okay. So the point we get is 2 and -10. Okay. So in this round, we only get one intersection. So if I try to graph that, it'll look like 2 and -10 right there. And so our line is going to go like that. Okay, so it's just touching at 1 point. So this line is 3x minus 16. We can test it by finding like the x-intercept and the y-intercept and stuff like that as well. So, so you can see that when we have our y-intercept here, x would be 0, so our y-intercept would be at -16. Okay? But yeah, so when we have a line that just barely touches a curve like that, we say the line's tangent. Okay? And so when a line is tangent, it just touches in one spot and one spot only. Okay? So for the last one, they want us to do the exact same thing, except with a different linear line. So we know that our original is still x squared minus x minus 12. And this time, our linear equation is 3x minus 24. So same thing, we set them equal to each other like this. X squared minus 4x minus 12 is equal to minus 24. So we get to add 24 to both sides. And set everything equal to 0 with x squared minus 4x plus 12. Okay? Yep. Today's lesson should feel like a review of factoring and algebra and all that other stuff. Okay? So what would the factors of this one be? So we can't factor this like we normally would, right? I tricked you guys. Math trick. Okay, so you definitely want to use your quadratic formula for this one then, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so here we know that our a is equal to 1, our b is negative 4, and our c is 12. So we'll get negative 4. Okay, Josh, focus. Which gives us 4 plus or minus, so we have 16 minus 48, so negative 32. Exactly. So because we have a negative here, we have no solution. We can't even take the square root of that. So when we have no solution, this means we have no intersects. So those lines will never, ever meet. Okay? So if we were looking at our graph, I know it is a little bit sad, the line would look something maybe like this, right? It wouldn't touch it at all. Okay? So now for some notes. This stuff is pretty straightforward. It says, if the graph of the linear and quadratic equations intersect at 2 points, the linear quadratic system has 2 solutions. Okay? If they intersect at 1 point, how many solutions do we have? And if they do not intersect at all, how many solutions? 0. Good one, Aaron. Okay? So, the second part to this, though, is if you had a question that was asking, instead of asking, oh, what are the coordinates, if it just said how many solutions are there, or how many intersects are there, you don't have to solve the entire system. Okay? So you can use the quadratic formula to help you. And if you remember all the way back to that unit, the discriminant is everything that's under that square root sign. So when the discriminant is positive, just like in quadratic equations, it means we have 2 solutions.